Now another way to do this problem on more modern calculators is if you press math, you can actually just scroll down to summation, and you can plug in everything right there. So that's another option available. Find a sub n and a sub 6 for the following sequence. So here we have to find out what the sequence is. It's arithmetic, which means that a sub n equals a sub 1 plus n minus 1d. That's the formula. We can look at the difference here. This is 16. This is 16. This is 16. This is 16. So d equals 16. A1 is 8. So you can guess what the next one is going to be. Plus 16 is going to be 88. That's one way to get it. To use the formula, we have a sub n equals 8 right here, plus n minus 1 times 16. We can clean this up. 8 plus 16. N minus 16 is 16 and minus 8. Let's check it. If I plug in 6, so a sub 6 is 16 times 6 minus 8. 16 times 6 is 96, minus 8 is 88. So it does work. So our answer is this, and then a sub 6 equals 88. Now, I don't know why. I mean, this is the same as what the answer key has. They write it as 4 times 4n minus 2. I mean, you can see that these are the same. Not really sure why they would write it that way. But it's the same answer. Find the sum of this arithmetic series using a formula. So we're basically adding. The formula here is, it goes up by 2 each time, right? And it starts with 1. So d equals 2 and a sub 1. The first one is 1, right? So make sure that looks like an equal is not greater than. A sub 1 equals 1. So a sub n equals 1 plus n minus 1, 2. Or 1 plus 2n minus 2, which is 2n minus 1. So this is our formula, and it works. You plug in 2, it's 4 minus 1 is 5. Plug in 3, 6 minus 1 is 6, and so on. So we're basically adding. We're finding what is 1, k equals 1. And the formula here is 2k minus 1. The question is, what is this going to be? So we can calculate that by plugging in 661 equals 2n minus 1, but this is going to be a sub n, right? Well, to find out what n is, you solve it right here. So we add 1 to both sides, then we divide by 2, and that gives us n. This is going to be 331. You plug in 331 here. Now you can go on your calculator and add this 331 times. You can use the calculator, your new found summation notation to do this, or what we're going to do is use a formula. So the formula here is, if you recall from the last chapter, S sub n equals n over 2. You add the first one, and then you add the last one together. So in this case, it's going to be the sum equals 331 divided by 2 times the first one, which is 1, plus the last one, which is 661. This is 662 divided by 2 is 331. This is just 331 squared, which is 331 squared. I mean, you could, I was just trying to do it by head as far as I could. You could have just put the whole thing in. So it looks like it's 109,561. 109,561. And let's try doing it with our newfound tool here. Summation. This would be n equals 1 to 331, and the formula is right here, 2n minus 1, and here 109,561. Find the indicated term of the geometric series. The geometric series is a sub n equals a sub 1 r to the n minus 1. So a sub 3 right here equals a sub 1, which is 2r is negative 6. N minus 1 is 3 minus 1. That's 2 to the 6 squared is 36, and that's 72. So a sub 3 equals 72. Find the common ratio. This goes down by a third. This goes down by a third. No, it goes down by a fifth. My bad. This is a fifth, so 0.2. This is a fifth, 0.2. 0.2, 0.2. So r equals 0.2. Find the sum of the first n terms. So this is a geometric sequence. So a sub n is going to be a sub 1 r n minus 1. The first term is 4. The ratio is this goes up by 2, this goes up by 2, that goes up by 2, and so on. So it's going to be times 2 to the n minus 1. The formula here is S sub n for geometric sequence is a sub 1 times 1 minus r to the n plus 1 over r. Sorry about that. That was n, and then 1 minus r. And yep. So S of 11, the sum of the first 11 terms would be a sub 1 is 4 times 1 minus 2 to the nth power, which is 11. Make that a little bit nicer. 2 to the 11th divided by 1 minus 2. 2 to the 11th is, I think, 2048 maybe. So 4, we'll put 4 times 1 minus 2 to the 11th. And the bottom is going to be just 1 minus 2, so divided by negative 1. So this is just 8, 81, 88. And last but not least, find this sum. This looks like it goes down by a third, goes down by a third, goes down by a third. So r equals 1/3, a sub 1 equals 5. Now this is an infinite sequence because it goes on forever. This formula here is like the last one. Now what happens here when n goes to infinity? This, if it's less than 1, this is going to get really, really small. So this just goes to 1. So then we're just left with a sub 1 over 1 minus r. So a sub 1 over 1 minus r is 5 over 1 minus 1/3, which is 5 over 2/3, which is 5 over 1 times 3 halves, which is 15 halves. And that is it. And we got 100%.